All right. Welcome to the 8th annual reInvent conference. It's our favorite time of the year where we talk a lot about solving various data migration and data replication related challenges for our customers. My name is Arun, and I'm a product manager with the database migration service team. We also own the schema conversion tool. And I have no words to express how privileged and ecstatic I feel to be representing my entire team to show you guys what we do to help solve multiple data migration and data replication challenges for our customers. And as part of the session today, we're also pleased to announce that we have Tulika Srivastava here, who is a software architect from Autodesk. And we are going to share a real-world enterprise migration scenario where Autodesk migrated their single sign-on platform from SQL Server on EC2 to Aurora MySQL. So just to get into the agenda for today, I'm going to introduce you guys to various aspects of the database migration service and the schema conversion tool. We will talk about product highlights. We will talk about what we've done over the past 1 or 2 years to solve various challenges and various use cases for our customers. In short, it's a logical replication Swiss Army knife, and we'll dive a little bit more into that. And once I'm done, Tulika is going to come on and spend about 30 minutes talking about the Autodesk use case of migrating an enterprise application like their single sign-on service from SQL Server to Aurora MySQL. Then we'll have Abhinav Singh, who is a senior database engineer on our team, who's helped migrate hundreds of databases for multiple enterprise customers, talk about some of the migration resources, and we'd be happy to open it out for Q&A after that. Some related breakouts. For this particular service, migrations are huge. Migrations are difficult multi-step projects to pull off. And we've been working really hard to get as many tools as possible to help our customers plan, convert their databases, assess, categorize, migrate, and move their data around within AWS or even into AWS. So multiple sessions there, and one session I would like to call out is the session with the same code, DAT362-R1. That is also going to be a customer use case where Job White, who is going to present their use case on migrating their SQL Server databases to Aurora MySQL. So moving on, let's talk a little bit about database migration service and schema conversion tool. Quick show of hands, how many of you have used or heard about the database migration service and the schema conversion tool? That's great, awesome, almost everyone. So we'll concentrate a little bit on introducing these services for the folks who have not really used the service, and then we'll dive deeper into some of the use cases and show you what customers have done. When you talk about migration tooling, we have two different tools. One is the schema conversion tool. What the schema conversion tool does is it makes heterogeneous migrations predictable. And by heterogeneous migrations, I mean migrations where you're attempting to move from one database engine to another database engine. What the schema conversion also does is it has abilities to give you an assessment report. It will tell you how easy or difficult it is to attempt that particular heterogeneous migration. And for a homogeneous migration where you want to keep the underlying database engine, like you want to go from Oracle to Oracle or SQL Server to SQL Server, it is also going to assess the effort to move that into RDS. So it will clearly tell you what features you're using in your on-premises database or database based on EC2, and how easy that it is to migrate to RDS with full functionality so that you can still keep meeting the SLAs of your application, right? And once your assessment and planning phase is done, the schema conversion tool also help you automate these conversions. So you could have secondary objects like stored procedures, functions, which could run into hundreds and thousands of lines of code. The schema conversion tool attempts to convert those into proprietary languages for the target engine so that you can accelerate these migrations as you go on from one engine to another. And once that is done, you go on to use a fully managed service like the database migration service, which easily and securely moves your database and migrates your data from one place to another in a near zero downtime fashion. It has abilities to do a one-time bulk load, apply all the cache changes that it's collecting during the bulk load, and then eventually keep the target in full consistency with the source so that when you're ready, you can just cut over your app to talk to the new target. So we'll dive a little bit more into these use cases. So in short, It's kind of a two-step process, right? One is you go in, you prepare your database. Let's say you're switching engines. You would want to create an empty database using the schema conversion tool and have a converted schema available in the target in open source or in RDS or in EC2 by itself. And or if you're attempting to do a homogeneous migration, you could just use the native tool to create a no data dump of your schema, restore it on the target, and have an empty database. And once you have an empty database, you can go in to move your data using the database migration service. And one exception here is, like we said, DMS and SCT, they are a logical replication Swiss Army knife. We also do have support to migrate on-premises data warehouses like Netezza, Greenplum, Teradata into Amazon Redshift. And we use something called the data extractor agents that you can install on-premises closer to these data warehouses so that it can orchestrate the entire process of moving that data to S3 and eventually copying that into Redshift. So we'll dive a little bit more into that use case as well. We have migrated more than 200,000 unique database instances using DMS today. You can see some of our customers on the screen there, some of them big enterprise customers who have migrated hundreds and thousands of databases. One important call out, again, you will hear a lot about it this reInvent. We've migrated more than 14,000 databases for Amazon.com from Oracle to Aurora Postgres and RDS Postgres. So you will hear a lot. There is a case study out there I'd recommend going through to talk about, which talks about their challenges and various best practices they use to migrate. And these are unique database instances. So if you actually look at the databases within these instances or the schemas within these instances, you're looking at a magnitude of about 5 to 8 increasing from a migration standpoint. Now let's talk about one of the first and most important phases of a migration. How do you plan and assess a migration? How do you look at the viability of a migration, right? So you'll have to do a couple of things. One, make a business case. You'll have to understand how easy or difficult a migration is. Then go in and do the actual conversion, which is what we're going to talk about in this section. So we have something called the Workload Qualification Framework that utilizes a special version of SCT, the schema conversion rule underneath, and it has abilities to classify and assess OLTP workloads running in SQL Server and Oracle and give you two important sets of reports. The first report is, it's going to give you an inventory report, which gives you important information about your source SQL Server or Oracle instance. For example, physical characteristics like the memory being used, the amount of disk space being used, or what sort of enterprise features you're using in these migrations, like always on in SQL Server replication, and so on. So it has abilities to look through that, and it's got abilities to give you more details about the inventory itself. And the second report is what does the actual categorization for you. As you can see on the screen, there are 5 different categories. Category 1 being basic ODBC, JDBC type workloads, which are easy to shift and move into another database engine altogether. 2, category 5, which could mean non-portable lift and shift type workloads, which could require refactoring in case you wanted to move that from a commercial database engine to open source database engine. So what the WQF analysis report, which is the second report, it gives you a clean cost model, which is on the screen right here. It's spliced across important migration steps on the left, which you need to follow to complete a migration. And on the top, you will see different personnel that are involved in a particular migration, right? So this is a cost calculation report for a sample SQL Server database. It was kind of complex with some stored procedures and functions in it. And we see that it takes about 80 days approximately for a 16-person team. And this is a dynamic Excel sheet. It's in OpenXML format. So based on your team's composition, you can go in and change these numbers to clearly have a business case around how much approximate time it is going to take for you to complete that migration, right? The other important thing in here is it does the same thing for Aurora Postgres and Aurora MySQL. And you can also do fleet-wide conversions. Let's say you have hundreds and thousands of databases. you can just give the tool a list of connection strings, and we will go in and do an assessment of this sort, give you a cost model, and give you an inventory report for all the databases that you've tried running in terms of migration from SQL Server or Oracle to Amazon Aurora, MySQL and Postgres compatibility. So now let's talk a little bit more about SCT. Like we said, it helps you make heterogeneous migrations predictable, helps you with code conversion tasks, database code conversion tasks. But what SCT also has the ability to do today is it can look at embedded SQL in your application code and try and convert that to be able to work with the target engine that you're trying to go into, among other things. For example, it can convert data warehouse schemas. It can even optimize schemas in Amazon Redshift. So it can look at your Redshift workload and see if you're using the right sort and distribution keys in your Redshift cluster, and give you details around what to change in order to improve performance and in order to go in and follow the best practices for Amazon Redshift. So like we said, we also have the support for data extractor agents that's shipped with SCT. It can sit closer to your multi-terabyte data warehouses with abilities to orchestrate the entire flow of moving it to Amazon S3 and eventually moving it to Amazon Redshift. And over the past year, we've introduced support for something called service substitutions. So let me give you an example to help understand what service substitution mean. For example, in SQL Server, we have a feature of database mail. Like you can use DB mail to be able to send emails based on certain events out to an SNTP mailbox, right? Unfortunately, a feature like that is absent in open source engines. So what we did is we used the ability to call synchronous and asynchronous functions in Lambda through Aurora MySQL, and we automatically emulated the way to call simple notification service through the Lambda functions from the database engine itself, and thereby entirely emulated the DB mail functionality in engines like Aurora MySQL, so that it's easier when you are reliant on a feature like that. So we did the same thing for queues, file management, among other things, and it's something our customers absolutely love when it comes to accelerated migration itself. The same goes with ETL modernization to AWS Glue. Today, you have the ability to look at Teradata BT scripts and Oracle Data Integrator scripts and move them into PySpark jobs in AWS Glue that work hand in hand with Redshift. So it's a click of a button based on the assessment. If everything is automatically converted, we generate the Python code for you so that it's ready for you to go in and test the performance in terms of using a serverless solution like AWS Glue to manage your ETL pipelines. So in short, when it comes to highlights, SCT can help you assess. It helps you stay ahead of some of the predictability issues you have when you're trying to move from one engine to another. It helps you plan those migrations. Once you're finished with the planning and you have a report to look at, I'll show you what the report looks like in the next slide. Once you have the report to look like, you can go in and convert the schema from one engine to another, and you can optimize it, optimize your spend in terms of moving from a licensed version of database like SQL Server or Oracle to open source like Amazon Aurora, RDS Postgres, RDS MySQL. And you can also use the data extractor agents to migrate the data warehouses into Amazon Redshift. So here's how the assessment looks like. All you need to do is SCT, install it on your laptop or an EC2 instance. We support multiple platforms. You connect to the source and target databases, and you run an assessment report, right? And the assessment report is clearly going to tell you what it takes to migrate, how much of the database is automatically convertible, and what needs manual conversion in terms of the action items you see on the right there. And a quick check on the SCT data extractors. We support those 6 different on-premises data warehouses today with abilities to move into Amazon Redshift. And the data extractor agents, they optimize the entire flow. They unload data into comma-delimited CSV files on the instance the extractor agent is running. It compresses the file. It uploads it to Amazon S3 in a bucket, and then copies it all over to Amazon Redshift. And the previous step before this is to just convert the schema and create the tables in Amazon Redshift with the right distribution style and sort keys and have proper WLM configurations for your workload. And once the planning and conversion step is done, at this stage, you will have an empty database on the target. Now it's time to move the data. It's time to migrate the data from one place to another. And that's where you use DMS. So DMS, logical replication Swiss Army knife, we support 12 different sources and 14 different targets, like you see on the screen there, with abilities to move from any of our supported targets to any of our any of our supported sources to any of our supported targets. For example, we support most widely used relational databases like Oracle, SQL Server, DB2, LUW, Sybase, and you have abilities to move that to the same engine or even to a different engine in case you wanted to create a new database portfolio for yourself. We are in the NoSQL space. You can move from MongoDB or Cassandra to DynamoDB and DocumentDB. We are in the analytics space also. You can create data lakes in S3. You can move data from S3. And we also have native Snowball integration. So in case you had to move multiple terabytes of data or move multiple databases at once and have yourself push data into the cloud as opposed to a remote DMS instance pulling data from your on-premises data center or on EC2, you could go ahead and use the Snowball Edge integration to be able to move data into Snowball first. The AWS personnel will make it available in S3, and then a remote DMS instance has the abilities to pick that up automatically and move it to a target of your choice. The only difference in here is the data warehouse piece. Data warehouses are typically multi-terabyte installations, which is why we designed it in a way that you migrate it using the SCT data extractor agents so that the extraction is closer to the source as opposed to pulling multiple terabytes of data over the network. So and even the extractor agents have abilities to get data into Snowball in case you are migrating multiple terabytes at once. So let's look at the migration process in general. So let's assume you have a set of application users connecting to your on-premises data center. You create a DMS instance in AWS, and that's the empty database. You could have SCT create an empty database, or you could have DMS create the tables by itself. Then you connect to the source and target. You create a couple of entities called the source endpoint and target endpoint, and you create and do a connection test. You select the table schemas or databases, and that's a powerful thing about DMS. You get to take what data you want. You're not forced to migrate everything. So if you have legacy data that you think need not go to the target, you have the freedom to do so. In terms of even chunking out tables, you can just take a part of the table too. So there are various ways to filter things out, and that advantage comes to you as part of the logical replication. And you just let DMS load data, keep the target database in sync. We have abilities to call database-specific APIs, look at the transaction log, know what changed, and migrate those changes to the target. And once in sync, we have full CloudWatch integration as well. So you can look at CloudWatch metrics. You can see how latent your target database is. And then once your database is in full sync, you can switch your application users to use the new database. And that's the only downtime you're going to have, which is why this is a near zero downtime solution. So some product highlights. Security is #1 priority, and DMS uses all of the security best practices AWS has got to offer in terms of VPC security. In terms of our compliance, we are a PCI, FedRAMP, SOC compliant service, to name a few of our compliance certifications. And in fact, even the underlying EBS volume attached to the DMS instance, which could contain data at any given point in time in certain cases, is also encrypted using a custom KMS key that is owned by you. So you have full control over your data. It's secure, and we move it based on the best practices available in the industry out there today. We have abilities to validate a migration before it starts, and even validate a migration as it runs in terms of on-demand data validation. So before it starts, you can look for unsupported data types, and we are adding a little bit more checks to that particular process today. But we do have data validation at scale, where you're able to validate the data that you're migrating from one point to another, or even replicating from one point to another, and the validation process that sits on top of the migration process keeps it in check in case there are mismatched records. It's going to report that out to you, and among other things in terms of compliance. In fact, Autodesk used a lot of validation, and you'll hear a little bit more about some of the challenges and the ways they solved their validation issues to meet compliance. Like we talked about, Snowball integration as well. You have abilities to move data to a Snowball Edge appliance first and then move that to AWS. We have full CloudWatch integration for your monitoring purposes. Logs are also stored in CloudWatch log streams, so you are fully informed about your migration. In case something goes wrong, you go into the CloudWatch logs and you know what exactly is going on with your particular migration. We have abilities to stream data. In fact, even though the service is named Database Migration Service, a fourth of our customers today are using this service for ongoing replication. So they really like the fully managed nature of the service and being able to automate everything. So we have customers who stream data into relational databases or even into analytics data warehouses like Redshift to be able to solve their analytical use cases, build data lakes in S3, or even stream data into Kinesis data streams to solve some of their streaming use cases. It is low cost. You pay for what you use. You pay for the underlying EC2 instance that is running the DMS software. And like we said, it's a logical replication Swiss Army knife. So you have multiple options of with being able to control your homogeneous and heterogeneous migrations. You can keep the engine. Typically, customers do that first piece, Oracle to Oracle there, typically for moving into RDS from an on-premise data source or data source on EC2. Or they use it to do in-place upgrades, like low downtime version upgrades, like minor and major version upgrades. For example, Postgres 9.4 is going out of life, and we have multiple customers using our service to upgrade their instances with little downtime to Postgres 10 or Postgres 11. So that is a big homogeneous use case for us. And of course, you have all those heterogeneous use cases that become even more powerful when you combine that with the schema conversion tool. So we have abilities to fan out. You can choose to use the same instance to go to multiple targets. Let's say you have a monolithic OLTP box that runs everything. You can use DMS to fan things out or even fan things in, especially things like consolidating shards into Amazon Aurora and other use cases. So we have customers who are fans of the microservices architecture. So they take it to services using DMS. They take their data to services that serve their actual need rather than having one single point of failure by putting everything together. So some very important use cases. We talked a lot about the modernization use case of moving into Aurora and moving into RDS in general. We have customers using it to do migration and replication also, and some of the use cases are on the screen here. We talked about most of these use cases, but we do have customers also in the migration use case archiving old data for compliance purposes into S3. And actually, there's a blog out there where they even take it to Glacier cold storage to save up on storage costs. So they use a fully managed service like this to get to a point where they have full control over their data and store it in ways so that they are in compliance with whatever they are trying to do. We also do have customers who've moved from relational to NoSQL or non-relational databases, or the other way around, being a heterogeneous logical replication service. We have customers who did that. In fact, Amazon.com moved a bunch of on-premises Oracle instances into Amazon DynamoDB to serve some of their use cases when it comes to the retail functioning side of Amazon. From replicate perspective, we have customers who run analytics in the cloud. They move from OLTP sources to sources like Amazon Redshift to take care of their analytical use cases. They use the service to hydrate data lakes. They create data lakes in CSV or Parquet format in Amazon S3 from multiple sources we support. They create read replicas and also a bunch of streaming use cases to Kinesis with abilities to transform data as you go from one place to another and get your data in JSON format to Kinesis. So with that, I will hand this over to Tulika, who's going to talk a little bit more about her use case of migrating the single sign-on service from SQL Server to Aurora MySQL. Thank you.
Thanks, Arun. Hi, everyone. I'm Tulika Srivastav, and I'm a software architect with Autodesk. Today, I'll be talking about our database migration from SQL Server to Aurora MySQL. And as part of that, I'll be talking about the database architecture we had before migration, reasons for migration, our migration strategy, what were the lessons learned during the migration journey, and what do we plan to do next. But before I talk about any of the technical details, I would like to share who we are as a company and what we do. Autodesk makes software for people who make things. So if you have ever driven a high-performance car, admired a towering skyscraper, used a smartphone, or watched a great film, chances are you have experienced what millions of Autodesk customers are doing with our software. Autodesk gives you the power to make anything. Its vision is to help people imagine, design, and make a better world. And this year, we reached a record-breaking 4 million active subscriptions. This migration is about Autodesk's single sign-on service, which is a mission-critical service integrated with over 300 different products and services within Autodesk. It has a huge user base of 142 million users at the time of making this deck, with 90,000 registrations happening every single day, and serving a peak traffic of 145K requests per minute. Now, as this service is moving towards the future to scale and support 10 times load, we are primarily focused on improving the availability, fault tolerance, and resiliency of the service with, of course, cost optimization and less overhead for infrastructure maintenance. So let's get started with looking at the database architecture we had before migration. So we had self-managed installation of SQL Server on EC2 instances, where it was an always-on setup spread across multiple regions. We had one primary and two secondary nodes with synchronous replication in one region, and another secondary node in the other region, which was set up using asynchronous replication. And we had set up VPC peering between the two VPCs. Now, this setup provided us with many advantages, like high availability, zero downtime during patching, failovers, scalability and performance by routing the read-only queries to the secondary replicas with very less replication latency. So you might be wondering, if everything was so good, why did we move to Aurora? Well, after spending a few years with always-on setup, we realized that due to the self-managed complex database infrastructure, many of the incidents in the past 1 year were because of this. We had like EC2 instances with EBS volume having RAID 10 configuration. And due to this unique setup, we started seeing problems in different layers, like Windows Server failover cluster, storage, IOPS, and crucially, in many cases, it became very difficult to do the root cause analysis of the incidents we were facing. Another pain area for us was backup management, and especially with cross-region setup, where even though we had automated many of the manual steps, it was still a big overhead for us. Patching was one more area which was consuming a lot of time of our database engineers, especially in our case where we had to support multiple environments other than the production environment for various purposes. Again, provisioning a new node in a self-managed infrastructure is a time-consuming process. So moving to a managed database service like Aurora MySQL helped us remove all these infrastructure maintenance overhead and also gave us the ease with which we could scale up and down the infrastructure based on the load. And the reason we chose AWS Aurora as the managed database service was because our entire ecosystem was already present on AWS. Now let's talk about scalability. In always-on setup, it is the primary node which processes the read-only routing request. And it identifies that which secondary node the connection should get established to. Now, while this feature makes sure that every connection is actually routed to a healthy secondary node, it makes the primary node a bottleneck for scalability. If you look at Aurora MySQL, it has reader and writer cluster endpoints for the reader and writer instances. So this makes it easy to scale without making any instance as the bottleneck. And on top of that, Aurora also gives you the advantage on the number of replicas, where it supports 15 replicas in one region, whereas the max you can have in SQL Server Always On is 8. The third very big reason for us to migrate to Aurora was cost. When we did an initial analysis, we realized that we were going to save approximately 40 to 50% of the overall cost we were paying for our database every month. This was going to be a huge saving for us. And on top of all this, it was also about the ease with which we were able to migrate our data from the source database to the target database. We worked very diligently with the DMS team to improve DMS for our purpose. So let's talk about the migration strategy. As part of the migration strategy, we had to take care of 4 major areas. Schema migration. Under this, we actually migrated the schema and the database objects from the source database to the target database. Application migration. As part of this, we designed the application in a way that it can work seamlessly with Aurora MySQL post-migration. Data migration. This was the scariest part because here we had to touch the customer data and move it from the source database to the target database. And like I mentioned, that our single sign-on service is a highly available service used by millions of users around the clock. So we wanted to avoid any downtime during this migration. But after several test runs, we realized that in order to achieve a clean cutover, it was best to incur a small downtime. Rollback plan. Okay, so I'm coming from Sydney, Australia, and recently we had a catastrophic level fire alert. We were issued a list of do's and don'ts from the council, and we were asked to be ready for evacuation in case of any emergency. The notice which was issued to us from the Rural Fire Service said that we have to be prepared for the worst and hope for the best. And that is what exactly is a backup plan or a rollback plan. So it is always prudent to have a rollback plan for your production migration systems. And that's why we came up with a backup plan so that in case of any problem with the application after cutover, we should have the ability to go back to SQL Server, the original source database. All right, so let's look into schema migration now. Due to the complex nature of data we had and the schema required to store such data, we decided to do the schema migration on our own. And as part of that, we created a knowledge base for our team where the difference between the source and the target schema migration were documented properly. I would like to talk about some of the challenges we faced as part of this migration. As you know, that this was a heterogeneous migration, so the char set and collation from the source and the target cannot map properly. For example, we didn't have a collation in MySQL 5.7 which could support case-insensitive and accent-sensitive search. So we worked very closely with Aurora team, and they helped us by backporting this feature from MySQL 8 to Aurora 5.7. Again, we had to do a lot of trials to figure out what would be the most suitable char set to support all the data we had in the source in the target. So we had UCS2 char set in the source, and we had to use UTF-8 MB4 in the target database. But the good part of that was we were able to reduce the database size considerably because of the choice of this char set in the target database. Similarly, if you look at the date-time precision, there is a difference in the date-time precision between SQL Server and Aurora MySQL. And if you choose the default date time for MySQL, chances are that post-migration, you would end up with precision loss of your data. Then we had to deal with the store procedures, functions, and events migration. So what we felt was that, due to the complexity of so many cassette, collation, and different data types, it was very important to automate the entire schema validation process. And that's why we came up with an in-house schema validation tool which could validate the difference between a given source and the target schema. This tool could validate from very basic stuff like number of tables, store procedures in source and target, case sensitiveness of table name. I'm sure anyone who has migrated from SQL Server to MySQL could relate to that. Number of columns in a table, to complex stuffs like ordinality of the column, data type, char set, collation, min-max value allowed, precision, and many more such things. It also helped us to validate indexes, foreign keys, default constraints. So it was a pretty generic tool, and we do plan to open source it very soon. Application migration. We used nhibernate in our application to connect to the database layer. And around 80% of our queries were generated by this ORM layer. So with very minimal changes into the ORM configuration, and by converting the remaining queries and procedures, we were ready for switching to Aurora MySQL. But we had taken some important design considerations as part of the application migration. We wanted to control the read-write traffic pattern through a configuration change rather than any deployment. So when I talk about, in the coming slides, about the data migration process in detail, there's a step where I need to stop the write traffic to the source database just before switching to Aurora database. We were able to do that very easily with the help of feature flags here. Again, we wanted to manage multiple database configurations depending upon our environment so that we could continue to release new features and we don't get blocked by the migration work. Again, feature flag came to our rescue, and we were able to achieve this by switching to Aurora MySQL during the database cutover without any downtime. One of the crucial requirements we had was to support seamless behavior of the application during Aurora MySQL failovers. Now, a failover is an event where a secondary node is promoted as a primary node based on its priority in case if the primary node is unhealthy. And we were using .NET Full Framework, but unfortunately, the MySQL driver for .NET Full Framework and nhibernate doesn't support Aurora MySQL failover, which essentially means that your application will not be able to recover in case of such failures. So what we did was we created an in-house implementation for this as a workaround to this problem so that the application can continue to serve the traffic even in case of such failures. Data migration. We use DMS for data migration. And like Arun mentioned, it's a great tool for migrating, replicating, and validating the data in a secure and cost-effective way. We used a design pattern for our migration and the rollback plan called roll forward. This design pattern had three major components: source database, which was SQL Server always on for us; target database, which was Aurora MySQL for us; and rollback database, which was a replica of the infrastructure of the source database. So let's look into the details of the migration process. This is how the initial setup looked like, where the application was pointing to the source database. And this was the step where we created the schema into the target database, which was Aurora MySQL, and the rollback database, which was SQL Server. And then we completed the DMS setup. Now, like Arun mentioned in the previous slides, that in a DMS setup, you first create a replication instance, which runs the DMS tool. Then you set up the connection endpoints for the source and the target. And then you create a DMS task, which migrates the data from the source to the target through full load by applying cache changes and by CDC or the change data capture. Full load is the process in which the existing data is migrated from the source to the target. Cache changes are the changes which are applied to the tables which are being loaded as part of the full load process. And CDC, or change data capture, is the process in which the ongoing changes are replicated from the source to the target database. Now, as a best practice, for full load, we only created primary keys on the database. The secondary keys and the foreign keys should only be created after the full load has completed. The reason is, as part of full load, multiple tables are loaded in parallel, and that can interfere if you have enabled foreign keys amongst different tables. Similarly, if you create secondary index before full load, it will potentially degrade the overall full load performance because of the index maintenance overhead. So make sure that you're taking care of this when you're doing your setup. And after doing all these setup based on these best practices and guidelines, we started the first full load task, which was between the source database, SQL Server Always On, and the target database, Aurora MySQL. Once the full load task got completed between the source database and the target database, Aurora MySQL, and it stopped after applying the cache data changes, we started the second full load task, which was between Aurora MySQL as the source database and Rollback database as the target database. And then we waited for the second task to get completed. And once the second task stopped after, again, applying the cache data changes, this was the time when we created the indexes and the foreign keys on Aurora MySQL and the Rollback database. Now, again, as a best practice, you should only have the writer node in Aurora MySQL during full load process, and the Rollback database should only be present on the primary node, and it should not be added to the always on database. The reason is, full load works best and more efficiently if you're working it against a single node. Similarly, index creation is more seamless if you're doing it with a single node, especially if you have big tables in your database. So now making the target database and the Rollback database as a highly available system by adding the reader nodes after full load and creating the indexes and foreign key was a key requirement for us before we could cut over to either of these databases. But it is, again, a use case dependent thing. So if your use case doesn't require a HA setup, you can actually defer this step and do it after switching to Aurora MySQL as well. Now let's talk about validation here. We relied completely on DMS for the validation. I would like to highlight a very special feature of DMS here, where you can write your own custom validation functions and use them in the validation task. And we heavily use this feature to do the validation for our special cases, like special characters, blob data type, multi-byte characters. Again, the validation can be started during full load, or it can be done during CDC or change data capture step. But if you are going to enable CDC later on in your migration, then as a best practice, you should disable the validation during full load and only enable it during the CDC or the change data capture step, because that is more efficient to do. I would like to talk about a QA practice here, what we did as part of the completion of full load. We wanted to validate some of the important workflows with our application-specific data. So we did a round of sample validation of some of the important workflows and ensured that the application is working fine for these workflows after the full load got completed. And this validation was done on top of the validation done by DMS for us. So once we had completed all these setup and we had made the setup HA, we completed the sample validation for the key step, we enabled change data capture and the validation for both the tasks. And all through this while, we kept on monitoring the key CloudWatch matrix for migration. And once we noticed that the CDC latency between the source and the target is a low number, and the pending validation overall count has reached a low value, we knew that we were ready for cutover. But again, as a best practice, you should try to reach this state at least a day before your scheduled cutover time. The reason is, it gives you enough time to plan for any mitigation, for any unexpected problem which can happen during this entire migration process. So we too planned the same way, and we reached this state 1 day before the scheduled cutover time. And at the time of the scheduled cutover, we stopped the write traffic to the source database, waited for the pending records to get validated, and then we stopped the DMS task between the source database and the target database. And after that, we switched the application to point to the target database. Now, the change where we stopped the write traffic to the source database and switched the application to the target database are the ones what I talked about managing through configuration in the application migration slide. After switching to Aurora MySQL, when we noticed that everything was healthy and it was all looking good, we still kept on running the second DMS task, which was between Aurora MySQL as source and the rollback database as target, and observed it for a few days for the peak and off-peak traffic patterns before we concluded that we are not going to go back to SQL Server anymore. And that was the time when we stopped the second DMS task between Aurora MySQL and the rollback database. So this is how our final setup looked like, where the application was pointing to Aurora MySQL. Now let's talk about the rollback plan. It was a backup plan for us in case the application behaves unexpectedly after switching to Aurora MySQL. So in this case, we had planned that we would stop the write traffic to the target database, which was Aurora MySQL, wait for the pending records to get validated, and then stop the DMS task and switch the application to the rollback database. And this way, we could have gone back to the old setup without any data loss. Now, one of the very important things in the rollback setup would be to make sure that you are testing it enough times to ensure that your application will not have any kind of data loss once you switch to rollback database. This is how our database architecture looked like after Aurora migration, where we had one master and two replicas in one region. And we had a cross-region replica in the other region acting as the DR. We had enabled routing of the read queries through reader cluster endpoint, and the remaining queries were routed to the master through writer cluster endpoint. We also did some application performance analysis against SQL Server and Aurora MySQL. And as you can see from the graphs, which is showing average query time in milliseconds, we did notice performance improvement after moving to Aurora MySQL. Lessons learned. So I have been talking about some of the best practices throughout this presentation. I'd like to share a few more key takeaways here. Multiple rounds of test runs. We did exhaustive test runs, and we did it in two ways. One was with the scale of the data, and the other one was with the real production data. So with the scale of data, we were able to test all the steps. And along with that, we were also able to test the switch to Aurora and the rollback step. And with the real production data, we were able to test it till the step where the CDC latency between the source and the target catches up. With that, we were able to get many useful insights, like how the actual production migration will behave with the real data, or what will be the downtime for me during the actual cutover. And with that, we were able to come up with the final migration plan. And these iterative tests also helped us in doing the capacity planning for different environments we had. Performance testing. We conducted multiple rounds of performance testing against Aurora MySQL. And with that, we were able to fine-tune some of the important queries which were showing difference in execution plan between the source and the target database. Fine-tuning configuration parameters. We actually worked on optimizing a lot of configuration parameters for DMS and Aurora MySQL. And with that, we were able to reduce the overall migration time to a larger extent, and in some cases, errors as well. Automation. It was because of automation that we were able to run so many tests so many times and so fast, because we had automated everything from DMS to database setup to alerts and monitoring. And talking about alerts and monitoring, we had set up enough alerts and monitoring so that any unexpected problem could be notified to us, and we don't need to babysit the migration process. And with that, we got very useful information, like by just looking at the pending validation overall count graph, I could tell that if there was a recoverable error in the validation task, or it could tell me that what will be the downtime for me during the actual migration. All right, so what's next for us? Further cost optimization. Like I mentioned in the schema migration slide, that due to the choice of the char set, we were able to reduce the database size considerably. And because of that, it gave us the opportunity to optimize the instance type further and save cost. Moving to Aurora also gave us the ease with which we could scale up and down the database infrastructure. And this gave us the flexibility to use lower instance type in our pre-production environments and scale them up with a click when needed. Better utilization of replicas. So far, we have not been able to route all our queries to the replicas. And the major reason for that is replication lag. So we have come up with some ideas, and we are planning to work on them to better utilize the replicas and route majority of our queries to them. We also want to work on Aurora auto-scaling to manage the peak and off-peak traffic patterns more efficiently. And finally, we are looking forward to exploring global database and multi-master when they are available in Aurora 5.7 for zero downtime patching, high availability, and scalability. And that's all from my side of presentation. Now I'll hand it over to Abhinav Singh from DMS team to talk about the migration resources.
Hey guys, my name is Abhinav. So with regards to whatever we talked today, I'm just going to talk what else is present today with regards to the tools that we just mentioned in the presentation, and how you can better plan it or better learn about these tools before doing hands-on or before starting your migration or replication projects. So with that said, we have something called playbooks. Before you even doing heterogeneous migrations from SQL Server to MySQL or Oracle to Postgres, it's a technology change. And also with these databases, there are certain features that you use in these commercial databases which might not be present in the open source database that you are going to select. So that's where we have written playbooks. What these playbooks encompass is just giving you a side-by-side comparison of each and every feature that is present and what is the equivalent feature present in that particular open source database. So let's say if you are going from Oracle to Postgres, or if you are planning SQL Server to Postgres, right? How you can replace Oracle's transparent data encryption with Postgres native encryption that is present? How you can replace SQL Server always on with what Postgres offers? So things like that. With regards to what is the equivalent feature that is present, or if there is any workaround that you can use to implement this accordingly, are mentioned in this playbook. It's a very comprehensive playbook of all with 300 plus pages. Please make sure you sit down while you are reading it. And it's just one more effort from our side to help you understand how migrations or how migrations are, and how you can plan it beforehand before even going for the actual hands-on experience. Database freedom. So database freedom is a program from our side, where we help customers engage with experts from our side to move off from the commercial databases like Oracle, SQL Server, Cassandra, Teradata, to native Amazon services like DynamoDB, Postgres, or Aurora. You get to talk to our experts on how you can accelerate this migrations. What are some of the best practices that we have to offer? What needs to be taken care of before starting the migration process? How the migration process should be done? What all things are involved in the actual application code conversion with regards to onboarding these new open source databases in your organization, and how you can take forward in terms of QA testing, in terms of going live when you migrate it, and maintenance of the same. So this is a program that we offer from our side so that customers have a better understanding of how they can plan this way in advance. Some of our AWS certified partners in the same field with regards to migration to AWS. These are some of our partners. We definitely also encourage working with them, and they also help you do the same thing, engaging with us, engaging with the database freedom team, and carry out the projects efficiently. This is one of the relatively new service, AWS IQ. What this service is, what the service does or help you is basically bridge the gap between Amazon resources and your migration projects. So using this, you can learn about how the usability testing that you can perform with regards to migration, how you can engage with the experts that I was talking about with regards to partners and database freedom team, and easy on access management and getting to know more about your actual migration and starting it on an accelerated path if that's the requirement. This service is definitely going to help you. If you have some more questions, or if you have any queries about this, they have a booth set up specifically in Venetian today, as well as on Wednesday at the time that you can see there. Last but not the least, the documentation, the resources part. If you are looking towards reading about how actual database migration services work, how validation in migration works, how code conversion, generally schema conversion tool performs the code conversion, or if you are looking to integrate it with your CloudFormation or your Terraform, like Terraform to do this, to integrate this service with your fleet-wide migration process, then these are the documentation highlights that are present on our AWS migration console, and we recommend customers to go there and learn more about this. We also launched a database certification program. So you can get certified in any of the Amazon database services that we have to offer, like DocumentDB, Neptune, Aurora, and since this is re:Invent, we have certification centers as well where you can go and know more about this, as well as the website aws.training for the same. Here, since we are done with the session, I would definitely request you to please rate the session. It would help us to understand how we delivered the session. If there was any issues, like you were not able to hear us properly, or if there was any concerns on that side, it would help us to make it better going forward. Thank you very much.